All right, so the first one is going to be new to us. I would not expect to see law of cosines this week because we're just now starting it. Law of sines would be fair because we started that last week, but law of cosines is brand new to us. It says determine whether law of sines or law of cosines is the best choice to find x, and then we're going to find x. What is 7? A side. And then what is 12? A side. What is 10? A side. And with side, that tells us to use law of cosines. Remember, if you need a refresher, law of sines is if we have angle, side, angle, 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 side, or side, side, angle. And then law of cosines is if we have side, angle, side, or side, side, side. And that covers the 5 situations that you could have. So side, side, side tells us to use law of cosines. Let's go ahead and label our triangle big A on a corner, big B, and big C. Angles are usually labeled with capital letters, and then the sides that are opposite of those angles are the lowercase letters. So opposite of big A is 12, that's going to be little a. Opposite of big B is 10, that's going to be little b. And then opposite of big C is 7, that's going to be little c. And then from here, I'm trying to find what? Angle what? Of what? Which one? Angle B. So I need to find angle B. So that means that in law of cosines, where's the only place to put an angle measurement? Refresher on law of cosines from yesterday. So take a look, like maybe the first equation. Where's the only place to put an angle measurement? At the end inside cosine, right? So if we're looking for angle B, it's going to have to go inside of cosine at the end. If we end with big B, that means we have to begin with little b. So that kind of tells us how to set it up. So we're going to use little b squared is equal to, this part models Pythagorean theorem. So b squared is equal to, let's use a squared plus c squared. And then you want to subtract 2 of the 2 letters you just used. So a and c. And you multiply that by cosine of, if we started with little b, we end with big B. And that's why we used that version, is because we need big B. So we used the one that had big B on it. What is little b? 10. So we'll have 10 squared is equal to, what's little a? 12 squared plus little c. 7 squared minus 2 times a was 12 times c was 7 times cosine of big B is the one that we don't know. I talked about this yesterday. It's nice when you don't know a side because you can start with that side and just solve the right side of the equation and then take the square root like we did yesterday. This time we have big B that we don't know, and it's inside of cosine, and there's quite a few things happening to cosine. So this one's a little bit different than yesterday. Let's go ahead and do 10 squared. What is that? 100. And then I can't type in the right side like I did yesterday because we don't know what B is. So I can't type in cosine of B because I don't know B. 12 squared is 144 plus 7 squared is 49, and then minus, oh goodness. Okay, which 2 numbers do you want to multiply first? 2, 12, or 7? 12 and 7? Okay, let's multiply 12 and 7. You're going to have a calculator for this, so it's 12 times 7. Actually, just type in 2 times 12 times 7 and tell me what that is. 84? Is that 12 times 7? 168, so that's times 2. Good. What is 168 doing with cosine? Multiplying. So multiply by cosine of B. So you can use the calculator to help you with some of these calculations, but you can't just type in the entire right side like we did yesterday. How do I solve an equation for a variable? Nope, not yet. So if it were just numbers, we would go in the order of operations. If we're solving for a variable, we need to undo the order of operations. So order of operations, remember, is parentheses, exponents, multiplication, division, addition, and subtraction. And we want to undo that. So tell me the things that are adding or subtracting on the side with cosine. 144 and 49. Let's go ahead and undo those. How do I undo those? Subtract them. So let's subtract 144 and let's subtract 49. Subtract 144, subtract 49. I'm doing that in the same step. Hopefully we are okay with that. And tell me what that is when you get it. Negative 93. And that's equal to your 144 and 49 went away. Don't forget that negative on 168. It is negative 168 times cosine of b. Is there anything else adding or subtracting on the side with cosine? So the 168 is negative. What's it doing with cosine? Multiplying. So there's no addition and subtraction left. We're done with that. There is multiplication and division, and that's the next thing we have to undo. So how do I undo our multiplication and division? Divide by what? Negative 168. So divide by negative 168. Tell me what that is when you get it. 0.554. Can anybody confirm? Good. And that's equal to what? Cosine of b. Good. Now there's nothing else happening to b except for cosine. How do I undo cosine? Inverse. So b is going to be cosine inverse of 0.554. Use that decimal if you can. Measurement of angle b is equal to. What we get? What? Is your calculator in degrees? Anybody else get 56? So remember this is an angle, so how do I round it? Just 56. Nearest whole number for angles. Some of us did get some points taken off last test because you rounded an angle to the nearest 3 decimal places. Angles go to the nearest whole number. And try to put degrees on there so that I know that you know that it's an angle measurement. Yeah. All right, we're going to practice finding the best method and then finding the indicated values in the diagram. I'm guessing in number 2 they want us to find the hypotenuse, which is C. How could we do that? Pythagorean theorem. Tell me why I don't even have to write down Pythagorean theorem. Yeah, it's Pythagorean triple, so my work is going to be Pythagorean triple, smiley face, and C is equal to 5. You should know that 3 squared plus 4 squared is going to be 5 squared. If you don't, I would need to see that work just like how you did it on your starter. 3 squared plus 4 squared is equal to C squared, and then solve for C. If you know your Pythagorean triples, then awesome. Your missing side is 5. Questions on that one? What's my method on number 3? Similar triangles. Good. Similar triangles means that I'm going to have to set up a proportion for this. What's a proportion?
It's like 3 over 4.
Yeah, it's like a fraction, right? Yeah, it's a fraction. So x is proportional to what? 18. Okay. Y is proportional to what? So we need to pick something. If y is in the bottom triangle, we got to pick one in the top triangle. It would be 6. And then 5 is proportional to 9. Biggest thing about this problem is make sure you go in order. So x, I'm going to start with x, over 18. X is a part of the small triangle. The only parts that I know both parts to are 5 and 9. 5 is in the small triangle. 9 is in the big triangle. So make sure you go in the same order. I could multiply by 18, but I'm not guaranteed a calculator on this question. So instead, I'm going to get common denominators. How would I do that? Multiply by what? Yeah, multiply by 2 over 2. Why am I multiplying by 2 over 2? Yes, I need common denominators, but I can't change the quantity of that fraction by only multiplying the bottom. I have to multiply the top as well, because what is 2 over 2? 1. So that's actually what we call a well-chosen one. You'll hear that through all your math classes here. It's called a well-chosen one because we choose it wisely to do what we want it to do, but it's still just equal to 1. So we've got x over 18 is equal to 10 over 18. How can I solve for x? multiply each side by 18. The nice part about this is that your 18s just undo each other, and it leaves you with x equals 10. I do also have to solve for y, and so y is proportional to 6, but this is the tricky part. Y is a part of the big triangle, so we have to pick a part of the big triangle. What do you want to pick? 18 over what's its proportional part in the small triangle? X, which is 10. So we can use that since we already found it. And how do I solve this one? You could try to get common denominators. That's going to take a while. What's the greatest common factor in 18 and 10? 2. So we can divide both those by 2 to make them smaller. So I'll have y over 6 is equal to 18 divided by 2 is 9. 10 divided by 2 is 5. Now, what's bothering y? 6. Yeah, we'll just multiply by 6, and we'll have to muscle through that fraction, because it is going to be a fraction. What is 6 as a fraction? 6 over 1. So you're multiplying your numerators. 9 times 6 is 54. And you're multiplying your denominators. 5 times 1 is 5. Does 54 divide by 5 evenly? No. Do they have a greatest common factor other than 1? No. So that's where it stops. 54 over 5. You can get a fraction. You could also possibly get a negative if x and y were adding to something else to make it positive. So don't let fractions or negatives deter you. They are possible given whatever kind of problem there is. Questions on that one? Okay. You can. Like if you don't have a calculator, some people struggle with 6 times 18. So if you don't have if you can do that, like mental math, or you can do that out to the side, go ahead and do that. Some people can't do 6 times 18 in their head or without a calculator, so that's why we made the numbers a little smaller. Does that make sense? Okay. So number 4, a doctor uses a treadmill to assess the strength of a patient's heart. He sets the 48-inch long treadmill at an incline of 10 degrees. How high is the treadmill raised from its original position? So we got a treadmill. A treadmill kind of looks like this, right? That's fine. It's a treadmill. You know, like it's got like the little handles. Yeah, the little screen. Okay. And then it's raised from its original position, which is probably on the floor. I hope it's on the floor. If you're running on a treadmill that isn't on the floor, that's going to be a problem. The treadmill itself is 48 inches long, so which part of my triangle is that? The bottom side down here? That's where my treadmill is? The hypotenuse. So this is 48 inches. And it says set at an incline of 10 degrees. Where does that go? Which angle? The bottom left, so this one, 10 degrees. They want to know how high is the treadmill raised from its original position. Compared to 10 degrees, what side are we finding? The opposite side. So I'm going to put an X here, and that is my opposite side. The 48 is my hypotenuse, so what can I use? Sine. So sine of 10 degrees is equal to opposite side is X over hypotenuse is 48. The most challenging part about this, in my opinion, is drawing the picture and figuring out where all your things go. Once you have that, then it's just right triangle trig. How do I solve for X? Multiply by 48 on both sides. What kind of thing is X? How do I know how to round? It's a side length, so you're going to round to 3 places. Tell me what you get when you get it. Can anybody confirm? 8.335. Good. And what's my units? Inches. These were on the Ames a couple weeks ago. You practiced last week with the board problems and in your homework. Now it's on the Ames as part of a review, and it's on your homework. So where's it going to be? Probably on your test. Remember, you have a long test on Friday. It is all multiple choice, but it's going to take the whole class. So make sure to come in here on Friday with your practice ready to turn in, and your Math Excel work ready to turn in, because you're not going to have time to go back and look and show your Math Excel work. So make sure that's done. You've got about 10 minutes if you want to try to knock out your Math Excel right now, or you can work on tonight's homework. I'll be around if you have any questions. Yeah. If you have to make up your